What exactly is Google Cloud Platform? How is it organized? And what makes it unique? In this module, we'll orient you to the basics.
Hi, I'm Nigel Armstrong, presenting on behalf of Google. In this module, we'll introduce Google Cloud with a particular focus on how the platform is an excellent place to run your Windows workloads. Google has a huge expertise in running software at scale. You'll be familiar with Google Search, Maps, Gmail and G Suite, YouTube, Photos. These and many more applications are part of everyone's day-to-day life through the Google Chrome browser and Android cell phone. And now Google has shared its high-quality infrastructure with the rest of us with Google Cloud Platform. You'll be able to provision your virtual machines in Google's data centers and connect to them over Google's private global fiber network. Google Cloud Platform is a great place for people who rely on Microsoft Server operating systems and applications. You'll see how you can provision Google Compute Engine virtual machines with Microsoft's Windows Server and SQL Server, and run web applications written for the .NET platform on Internet Information Services. The concept of cloud computing began with co-location. Instead of operating your own data center, you rented space in a co-location facility. This was the first wave of outsourcing. With co-location, the transfer of ownership was minimal. You still owned the machines and you maintained them. Traditionally, co-location is not thought of as cloud computing, but it did begin the process of transferring IT infrastructure out of your organization. Today, cloud computing involves virtualized data centers, virtual machines and APIs. Virtualization provides elasticity. You automate infrastructure procurement instead of purchasing hardware. With virtualization, you still maintain the infrastructure. It's still a user-controlled, user-configured environment. This is the same as an on-premises data center, but now the hardware is in a different location. Virtualization does provide a number of benefits. Your development teams can move faster, and you can turn capital expenses into operating expenses. The next wave of cloud computing is a fully automated elastic cloud. This involves a move from user-maintained infrastructure to automated services. In a fully automated environment, developers do not think about individual machines. The service automatically provisions and configures the infrastructure used to run your applications. Google is uniquely positioned to propel organizations into the next wave of cloud computing. Google's first product on Cloud Platform, App Engine, showed in 2008 that anyone could develop and deploy scalable, highly available web applications without provisioning servers. And many key GCP products today are low or no operations. In Google Cloud Platform, all resources are organized by projects that provide a container for all the products on the platform. You'll provision resources within a project, and the project serves as an important identifier for billing and management of users and groups. Resources within a project are either global, regional, or zonal. Regions are independent geographic areas that consist of zones. Locations within regions tend to have round-trip network latencies of under 5 milliseconds. A zone is a deployment area for Cloud Platform resources within a region. It might help to think of a zone as being similar to a logical data center with independent power and network, and so zones should be considered a single failure domain within a region. In order to deploy fault-tolerant applications with high availability, you should deploy your applications across multiple zones in a region to help protect against unexpected failures. To protect against the loss of an entire region due to natural disaster, you should have a disaster recovery plan and know how to bring up your application in the unlikely event that your primary region is lost. The Cloud Platform services and resources can also be zonal, regional, or managed by Google across multiple regions. Zonal resources operate within a single zone. If a zone becomes unavailable, all of the zonal resources in that zone are unavailable until service is restored. An example of a zonal resource is a Google Compute Engine instance that resides within a specific zone. Regional resources are deployed with redundancy within a region. This gives them higher availability relative to zonal resources. An example of a regional resource would be a regional bucket for storing data in Google Cloud Storage. A few Cloud Platform services are managed by Google to be redundant and distributed within and across regions. For example, buckets in the United States location for Google Cloud Storage keep data at rest inside the United States, but at-rest data can be stored in or moved to any cloud storage region within the United States. Google Cloud Platform includes a wide variety of products, services, and APIs to enable you to build your applications, and these are organized into product families. The Compute family includes an Infrastructure as a Service product, Compute Engine, a Platform as a Service product, App Engine, and a hybrid product, Container Engine. Many Google Cloud Platform storage products operate at petabyte scale, including Bigtable, a NoSQL key-value data store, Cloud Storage for storing blob data, and Cloud Spanner, a horizontally scalable SQL database with ACID transactions. Google's big data products include BigQuery, which enables high-performance analytics at petabyte scale, Dataflow to run pipelines for batch and real-time transformation, and PubSub to support your application messaging requirements, all with no ops. Finally, Google's machine learning expertise is available via Cloud ML Engine to train your own machine learning models and host the trained models for online or batch prediction, together with best-of-breed APIs for analyzing images, text, audio, and video. From the perspective of managing Windows workloads, each of the Google Cloud Platform products is available via a REST API with client libraries. In addition, you'll be able to run your applications on Google's Compute family products. With Compute Engine offering Windows Server, you'll have support for any Windows application. For Container and App Engine, you'll be able to run Microsoft's new .NET Core environment on Google servers. As you'll see in the demo at the end of this module, it's straightforward to access Google Cloud Platform using your web browser, and there are two primary techniques. First, the Cloud Console is an easy-to-use web application where you can select a product using the Products and Services menu, then configure a server using just a few clicks. Alternatively, there's a set of tools available via Cloud Shell, a command prompt accessible from your web browser. You can also install the Google Cloud SDK locally to run scripts from your own machine as well. Of particular interest to all of us who are Windows Systems Operations professionals, there's a comprehensive support for PowerShell for managing Google Cloud Platform, including commandlets to manage virtual machines, and a file system provider for Google Cloud Storage. We mentioned previously that on Google Cloud Platform, you'll always create projects to manage resources. For Google Cloud Platform Enterprise customers, There's an additional container, the organization, which is created when you sign up with Google as a G Suite customer. Each developer or systems operations professional will have a login to access Google Cloud Platform resources. There are a number of distinct options for customers with Active Directory, including having separate G Suite accounts, synchronized usernames from Active Directory via Google Cloud Directory Sync, passwords with Google Cloud Password Sync, or single sign-on from Azure to G Suite. Once your users are all set up, then they log in to access project resources. There's a flexible identity and access management system that will enable you to configure role membership for groups of users to enable them to have just the access levels that they need to do their work.